Well, g'day and welcome to the shed. And today I'm not sure what I'm taking on, whether I want to do this or not. I've got this enormous Philips radiogram. My friend Dom has been twisting my arm to do this for a year or so since he picked it up off the Verge, and I've got to say, for a Verge pickup, it's pretty good. They obviously have a better class of rubbish throw out where he lives than around here, that's for sure. So let's have a look at it. Having a look inside, look at that. Beautiful. A few small marks on it. Philips turntable, and he's got a cartridge for it. I don't suppose this will work straight up. It'll need the usual clean and lube, if nothing else. Looks to be all there, and the turntable does turn. I'm not sure whether the mechanism does anything. Yep, it's doing its thing, I think. What it's going to do, I'm not too sure. I've never worked on a Philips turntable before, but now that doesn't have a stylus in it, so it should be okay. So the mechanism's releasing. There's a hole here that says start. There's something missing from there. We'll just have to pull it apart and see what the story is with it. The grill cloth is in nice condition. It looks almost like new. I think that Dom probably cleaned it up after he picked it up off the Verge, but it's got no damage on it at all. I presume this is record storage in the middle here, and from the size of these, I suspect it packs a couple of decent speakers behind here. I can't really tell yet, but we'll have a look in the back of it in a minute. Over here we have this very nice looking radio. All the knobs are intact. Very nice set of push buttons here. Very neat, much neater than the Bush radio that I recently did up. That's coming off a little bit there, but that can be fixed. It's got a magic eye. From what I can see, it is only broadcast band. I can't see any wave change switch, but we've got what's that? Gram bass, orchestra, speech. So it's got the kind of tone control setup that you might find on a German radio. Volume, tone, as well as these tone controls. Balance. So this is a stereo setup. Shows you how much I know about it. The tuning doesn't work. It's stuck. So that'll obviously need work. He said that he hasn't plugged it in, so that's probably a good thing. And if it was thrown on the Verge, you can pretty much bet that it wasn't working. I think the first thing to do is to take this out of its cabinet, and we'll have a look at it on the bench and just see what we've got to deal with. And I've moved it outside the shed so I can get at it better. It is rather cramped in there, and I do like to be able to walk around if I can. So let's get these screws out. Got quite a lot of screws holding this back panel in. Not your typical cheap fiberboard either. This is about a 1/4 inch thick plywood, I think, material. Looking in here, I'm not too sure how this is going to come out of the cabinet. Obviously got two output transformers there and there. Probably didn't have room on the chassis for both of them. Gee, I hope they're not open circuit. This lead here, possibly the input from the turntable, is connected to this big cable. Where does that go? Oh, that's great. That'll obviously need to be tidied up. This white wire here comes up to this little connector here. That side goes into the amp, that side goes off towards the turntable, and the input from the power supply, so that'll be heater and HT presumably, comes from this plug on the power supply chassis down here. So I'll need to pull all of this out in order to test it on the bench. And we have a set of 8-inch speakers, I think that would be. Finally got what seems like dozens of screws out of impossible to reach places, and the chassis is now free Something dropped, I don't know what that was. Well, here it is on the bench, and as I said, it has a separate power supply. I may as well have a look at this first. We'll just perhaps check the transformer. It takes its power from the main chassis via, I presume, the on-off switch. I don't think there's probably anything else in there. Washer there. So let's have a look underneath it. We've got two big caps here. These are 50 UF at 350 volts, another 50 at 350, and we've got a what is that? That's an 8 microfarad. So we've got 3 electrolytics here. I presume they're both single. Here we go. Just looking underneath. Obviously this is the primary coming in, and gee, these big fat wires would have to be the filament winding. That is really thick wire. So one side goes to the rectifier tube, makes sense. I presume it's an indirectly heated rectifier, 6CA. It's not one I've come across before. And the other side goes to this plug, which goes to the main chassis. That makes sense. It's got this brown wire which goes around to here and to ground. And a chance to try out my new multimeter. Only came in the mail yesterday. Turns out that it's made in China. It's a Fluke 17B, but by all accounts they're alright. Anyway, I've got it on ohms. I presume it's auto ranging, I hope so. So the primary first, and I think the primary is probably going to be okay. 17 ohms on the primary. I guess it's a pretty heavily wound primary. I doubt if we'll measure anything on the filament winding. Let's just have a look, just out of interest. We'll just go from there to there. It will be a fraction of an ohm, I would expect. 0.6. Now I'm getting 0.1 of an ohm. Anyway, that's what I would have expected for a winding like that. Okay, so the moment of truth, let's have a look at the secondary, and I guess that middle one's a centre tap. I'll go centre tap to the blue wire. I've got 110.7, and centre tap to the other wire. What's that, black, I think? 104. You'd expect them to be slightly different because the different length of wire to do the same number of turns. Okay, 214.8 across the two of them. I wonder if the centre tap to ground. No, the centre tap is not grounded. Okay, let's have a look up here. So these are the two caps here and here, and we've got these two resistors here, and that's what, brown, green, brown, so that's 150 ohms each, so 75 between the two of them, paralleled up like that. So we should be looking at 75 ohms here. Is that got the backlight on? Yeah, there we go. What do we got? 80.6 or 7. More or less 80 ohms. It's supposed to be 75. I think in this situation that won't matter. So that's, I guess, a conventional pi filter. Now from here we've got this, it says 3300 ohms, 3300 ohms, and it goes to this third 8 UF cap. I'll check that resistor. It looks like a wire wound. It's probably within 3405 from 3300. That's, yeah, look, that's probably okay as it is. Alright, so I don't know what that third cap is for. Perhaps an extra stage of filtering. Now these two, this one looks okay. I'll just get a bit more light on the subject here. So these are the 250 UF caps. This one looks alright. This one's got all this crusty stuff around it. I kind of think it's crumbly. I kind of think it might have been leaking. I don't know what it is. I think that cap is, well, I would change them anyway, of course, because of their age, but that one does look to have been leaking, so I don't think I would power this up without changing that. Yeah, that's that's probably seen better days. The transformer at least is apparently intact. I don't know exactly what DC resistance it's supposed to have, but it's not shorted. It doesn't look questionable at this stage. Now I have got a schematic which I've downloaded from Radio Museum, printed it off. It's one of these ones with 2 pages, and the 2 pages don't line up. If you line it up at the top, the bottom is, yeah. So anyway, looking at the power supply, and we've got the mains input here. This line's kind of faded out, goes through the switch. This will be on the keyboard buttons on the front of the radio. In fact, this whole dotted section up here I think is the keyboard section. Through that connector block up to here to the primary. Secondary, we've got a conventional centre tap rectifier, indirectly heated cathode that runs through. There's these 2 resistors. These will be those 2 150 ohm ones in parallel that measured 80 ohms, and the 2 50 mic capacitors, which is a fairly large capacitor in this situation, but there you go. Now we have this 3.3k wire wound that we checked. It was about 3.4, and there's the 12 mic cap, and then this goes straight out to the plug and onto the amplifier. So here we have the main chassis, and it's pretty messy. What is this? I think it's a common ground. There's a tag strip here with a whole bunch of coaxes, and they end up with these in these plugs here, DIN plug and something else. I guess that's an input for something. I have no idea what. Someone soldered some orange wires onto it, and looking at this, these 2 coaxes are hanging by a thread pretty much. I'll tidy that up anyway. Over here I've taken the speaker plug out of the cabinet, and it just comes to this terminal strip and then off to the speakers in the cabinet, so that's handy. I can attach this to a couple of shop speakers. I've got a couple of speakers there. I don't know if they'll be suitable or not. And the mains cord here, and I can see that it's been eaten by something there. The switch contacts all look pretty grotty and dusty, but I can't see any sign of damage. The dial string's broken, there it is, but yep, the tuning cap, oh, that's got a reduction drive on it too. That's nice. It's free, seems to move really easily actually. The dial pointer's just floating up here. We have these 2 output transformers here, so one here and one here. They obviously couldn't fit both of them on the chassis. I do hope that they're okay, because they will be a pain if they're not. Alright, well, let's have a look underneath. Oops, there's the dial pointer. I'll just turn it on its end for the moment. Okay, now look at this. Look at all these paper caps. There's dozens of them. Oh, look at this one. That's been chewed by something, a mouse I presume. There was a lot of mouse dirt in the cabinet, so I guess it's mice. I have to keep a close eye out for anything else being chewed by them, but that one looks like it's been chewed a bit too. Coax running everywhere. Now there's a couple of caps here, and they're black. I don't know if they would be. No, they've got a moulding line around the edge, so they're not new ones. Obviously they were, if they have been changed, they're before this one was damaged. Gee, there's so many of them. This one's been eaten. How many paper caps are in this thing? This is going to keep me busy for a long time, and I think I will have to probably change every one of these. Okay, so looking at this, this is going to be the aerial coil here and the oscillator coil there. They look to be intact at least. They haven't been eaten by mice or anything, so that's one disaster averted. There's a tuning spindle here, and that's pretty stiff. Tone, I think that was. and I don't know what that is. Balance perhaps. Well, that might be balance. That'll be balance. This will be tone. And the volume knob, I tried it when I was taking the knobs off it, and this is frozen solid. That is not moving at all. That's as crusty as I've ever seen. I can't move it. I'll clean that up and get some perhaps WD-40 into here to see if I can free it up. Otherwise it'll need replacing, I guess. Okay, so let's have a look at this output transformer. And looking at it, this will be the secondary. Goes straight to the speaker plug. It's got a brown, a red and a blue wire coming out of it, so it looks like it's a center tap output transformer. So the red wire goes along here up to here, so I'll take one side from here. We'll try where's the brown wire go? It goes to here, I think. So I'll just try that. That's the red one there, and the brown one there, I think. Yeah, well, we've got something there. We've got 332 ohms on that. So that's okay. So it's red to brown. We'll try red to blue. Where's the blue wire go? Down here on to here, by the looks of it. Let's see if we get anything across there. Yes, we are getting stuff there. We're getting, we can get a reliable connection here, contact. 375 and blue to brown. I think the brown goes to there. Oh, don't knock it over, Don. It would be unfortunate. It's got a nice dial glass on it, this one. I don't want to break it. So we're going blue off there, I think. Just off there. Not that ground wire, that one. To the brown was there. Gee, that's hard to get into. There we go. 0.7K. So 700 ohms. So that's probably looking right across the transformer. Looks like that one's got continuity at least. Where does the other one come out? I'll just slip a little wedge under it here. Yeah, that'll stop it from tipping. The other output transformer comes out down here somewhere. There it is there. It's hard to tell where its wires go to. There's a red one there. And there's a brown one goes up here to... it's very difficult to trace. Where does that go? That'll probably go to that valve. I think that's it there. Had something there. Yep, 337 ohms. That's from the red to the brown. And what else have we got coming out of that? Surely there's another wire. If one of them center tap, the other one will be. There's a blue coming out just there. And the blue goes to... goes to there. Okay, there we go. So that's the blue wire to the red, 373. So it looks like both output transformers have got continuity at least. That's a bit of a relief because being centre tap ones and a stereo pair, you couldn't just throw any old thing in. So I guess I'm going to have to change some of these caps before I consider firing this one up. This one's obviously damaged. These have been chewed. They probably all had it. I'll find out which ones are the grid coupling caps. It might be worth changing them before I start on anything too. And there's this little electrolytic up here too. Is probably a cathode bypass or something. Okay, so I put a knob on this volume control and my oldest, dirtiest, greasy rag underneath, and just try working a little bit of CRC into it. No sign of movement yet though. I might just have to let that soak for a while. I don't know if that'll do any good at all, but we'll try. Well, it's the next morning. It's been soaking overnight, and I've got this volume control moving a little bit. Just put a little shifter on the flat of the shaft, and I've got it going a bit, just working it a bit more. A little bit more WD-40. That seems to be helping. Yeah, we've got a bit of movement there now. And it's pretty much free for the whole of its travel now. It's still a bit stiff and catchy, but I'll put some more WD-40 on it, let it soak for a while. That's usable now, assuming of course the pot's alright. Okay, so I've got a couple of 47s, a couple of Carl's Finest, and I have actually got an 8UF. I didn't think I had any, so that's handy. I think I can probably fit the two 47s along the side here, and the 8 either next to it here or across that way. And with this one, because it doesn't go to ground, I'll just hook the end of this resistor and this other wire which goes to the case, to the negative, onto the end of it. I think that'll be stable enough. So let's just get this out for a start. We'll start with the resistor side of it. Well, that's just about it done. I'll just bend this down a little bit of clearance around this resistor because it's going to get possibly warm. That's not too close to anything. I've used the original positive tab from this 50 mic capacitor as a connection point because I've disconnected all the CAN connections, so this is now not referenced to anything. It's just a tab, a solder tab. Okay, so I think we're ready to go. I'll just shrink that up. So I'll just hook this up to a power plug and see what voltages we're getting. Alright, now I don't have the rectifier valve in, so I'm just going to put it onto dim bulb and just see what we're getting on the secondary here. And then I'll try the rectifier and see what unloaded voltages it's got, but they won't really indicate anything except I guess that the rectifier is working. Okay, so we got 232 volts going in, and center tap to one side of the secondary, 266, other side 6870. That's odd. 533 right across the secondary. I'll just check that again. So center tap to there. Oh, that's better. 264.2 on that side and 264.6 on that side. So that's pretty even. And as I said, 500 and something, that's scary. 534, 530 across the two of them. Okay, I guess our 6.3 volts is happening. I'll just check this. 6.5, yep. One slightly curious thing I noticed is that the positive side of this cap goes to the center tap eventually, but it's disconnected. I guess goes to this pin here. I don't know what's on this pin. This one here goes back to the center tap. So the center tap is just floating until you put the plug in, which connects to the chassis and has this link here that joins this and this one together. So the center tap is then referenced through that to the positive side of this cap. I don't know why they would have had it like that. I can't think, but anyway, so I can't really connect that up until I'm ready to plug the chassis in, and I'm certainly not going to apply power to this chassis just yet. So I'll put the rectifier valve back in, and what I will do is just jumper up this center tap. I don't know if it make any difference, but just want it connected, and I'm really not certain why they did that, but anyway, I'll put it straight to the center tap like that. And that's got a good grip on that wire, and it's not touching anything, I don't think. Yep, that's all right. So again, applying power via dim bulb. We had a little glow from the dim bulb, then it went out. So let's have a look at what we've got here. This side to ground. So what do we got here? 338, 940. We're still charging up the cap. 345. This one should be a touch higher because this is the first filter. Oh, the same. Well, there's no load on it, so that figures. Okay, and this one here, this is the third. 347. Yeah, well, they're all the same because there's no current flowing through it, unloaded. But at least the rectifier is working. So I'll just take that off, and I might just discharge those caps before I go handling it. So let's have a look at the chassis, and I've fitted, reused a wooden stand that I used on a previous chassis. In fact, I think I've used these on several radios now. Very handy. And I was just checking it over, and I noticed that the on-off switch doesn't seem to be doing anything. This, with the others, these come up. Well, that's interesting. So that comes there for on, presumably. These are tone controls. And the off one, oh yeah, so that goes on when you press medium wave or gram. And off. Okay. So that is working, I think. I'll actually just put a meter on it though and just check that it's doing what it should be doing. So I'll just check across this side. Open. When I put that on, it should be closed. Yep, 0.2 of an arm. And this side, .6. Probably the connection's a little bit dirty there. If I clean that, it'd probably come up, in fact. No, still nothing. Maybe it's 3.5 ohms. Could be the contacts are dirty, perhaps. Okay, so if I put that on, that's rather odd. Yeah, I suspect it's dirty. I'll try putting some WD-40 on the contacts or something. I don't know if I can get into them from there, probably. Okay, I'll see if that's made any difference. That's open. That's better. Alright, so that's that taken care of. Okay, well let's have a look underneath and see what we've got to deal with. And there's too many cords dangling from this thing. There's a little electrolytic there which seems to have popped its cork. Or maybe not. Another one there. Bigger one there. I guess I don't know. I'll have to have a look at the schematic really before I start on this. These ones have been well and truly chewed by mice or whatever. They're on the tone and volume controls. This may have survived actually, but so they don't have high voltage on them, but I'll change these anyway once I work out what values they are. I presume these will be the same for both sides. Okay, looking at the schematic, here's the volume control, at least that's the right and left ones here. We've got this 0.047 cap which goes to a 10k resistor to the wiper, and the same down here if I reline up this rotten schematic. Same thing here, 0.047 100 volts. So that's C26 and 25. They're badly chewed up, so I'll start with them. So here they are here, and just under there you can see those 10k resistors, one there and one's under this cap. I'll just cut them out, I guess. Let's see if they test okay, who knows. Okay. It's always nice when you can get the component leads out. Sometimes it's too hard, and I'm not going to be silly about it. If it's too hard, it's too hard. But these are easy enough. There we go. Hopefully just melt that and poke it through. There we go. And same with the other one. Now, I thought that was going to be facing the right way. Okay, that'll do. Two down, about 25 to go. So I replaced the ones that were eaten by mice. That's these two on the volume control, and also these two on the tone control were eaten by mice. And I thought, well, the next thing to do, I may as well replace all the coupling caps to the grid coupling caps, because you don't want plate voltage on the grids. This is a push-pull pair of output valves. These each have a pentode and a triode in them. Now, one of the triodes, the one for that, and I've colour-coded them so I know which valve is which. This is used as the preamp, and the triode of the second valve is used as a phase splitter. So we've got the plate going to this grid, we've got the cathode going down to the grid of the other valve, and that of course is duplicated down here. So we've got a coupling cap between the triode and the grid of the phase splitter. Then we've got a coupling cap from the plate of that to the pentode, and there's one from the cathode to the pentode, and although that doesn't have a lot of voltage on it, I thought if I'm changing that one, I need to change that one too, because if they're different substantially, you'd probably get distortion. And that of course is all duplicated down here. Then of course these 0.022 caps from the plate to the center tap of the output transformer, and the same down here, so there's 4 of them. So I've been fairly busy, although I haven't finished yet. Okay, so here we are. You saw me replace these 2 before. These 2 were also chewed by mice, and they are 0.0015. I've found a couple of green caps of the correct value. I've still got these 2 to change because they're 0015s as well, but I don't have any more green caps, so I'll have to go and buy some to replace them. I had everything else though. So there's all of these are basically the coupling caps I was pointing out. One there, underneath there. They're all over the place. So they're all done. Also haven't done these ones here. And here, these go onto the balance pot. And there's these 3 here in the RF section, which I also haven't touched yet. So I don't know what we're going to get. I don't think it'll be disastrous if any of these were really bad, and I suspect they might be. Some of the ones I've tested have been pretty good, others have been terrible, so it's pretty patchy. The resistors I've tested so far have been within spec. They're all pretty good, so if one's good, often the rest of them are all good too. So I'm just about ready to put some power on this and see what we get. Now my shop speaker is, and has been for ages, this crappy old car speaker that I've got screwed to the bottom of the bench here. This being stereo, that's obviously not going to cut it, and I've been thinking of replacing it anyway. Now I picked up a pair of these JBL speakers out of a rubbish collection. Again, it's amazing what you get out of the rubbish sometimes. And they both test perfectly alright, although I haven't listened to them. So I was going to use these, but they're only 4 ohms, and so is my bench speaker. So what I've had to do is take the speakers out of the cabinet, and I'll bring them in, set them up here, and we'll try it with them. So here they are, MSP high flux speaker, and they're a dual cone type thing. This one's in pretty good condition. It's got a bit of insect damage around here, a few holes, but certainly nothing that's not repairable. It doesn't scrape, and I've checked it for continuity, so that one's alright. The other one not so much. It's got quite a lot of insect damage around the top here. It's all eaten away. Still repairable. I'm wondering if this thing does sound half decent, whether it might be worth reconing these, though, putting in a foam surround, although they don't seem to last very long. I don't know whether I will be able to do that and retain enough flexibility for the thing to work as new. I'll give it a try anyway. So to keep these out of harm's way, I'm just going to screw them to the side of the bench here. So I've screwed these to the bench and hooked them up to their connector block. I've hooked a couple of leads up to the 2 B pluses, the first B plus which doesn't go to ground via the cap, and the other one which does. The third one I'm not going to monitor at this stage, but I'd just like to see what's going on. It'll give me an idea of how bad things are or how it's performing. And plug it into the chassis. That plug goes like that. I'll put this meter on the B plus, the first one. And I'll hang that somewhere out of harm's way. And I'll hook my other meter up to the other B plus. And I'll hang that there somewhere. Have to remember not to touch those. Okay, well I guess we're ready to go. Even cleaned up the plug because it was so crusty I didn't want to plug it in. So I'll just put that in there. It's on dim bulb. I'll put this on, but I think the switch here is off, so we'll see what happens. Nothing. Okay, so if I put it on radio, actually I'll put it on radio. Let's see what we get. Pretty bright, but it does have an extra tube. It's not full brightness. No smoke coming out yet, and no voltage coming up yet. Bulb's dimming up. The B plus is starting to come up. B2 plus is starting to come up. Now whether this globe will be too much restriction for us to hear anything. We got noise. We've got 110 volts on B2 plus and 110 on the other one too, about the same. So I'll just try turning the tuning dial here.
But as I've said at the beginning of this campaign, from day one, we will now work with the Parliament that Tasmanians voted for today. Form a new government. Goal to decide.
We've told live our lives like
Goldstein, who won the tap. He's right across this beautiful state. This is the best place.
Well, it seems to have reception right across the range, and it seems to sound all right. So that's good. I guess what I do now is I'll go on and change the rest of the caps, and there'll be any number of other things to fix up. And this is only on dim bulb too, so it might perform even better on full power. I'm not sure if I want to do that before I finish off the recap. I don't think it matters. It's working. That's the main thing.
Next 4 years, and I'm only
Goodo. Well, that's a pretty good result, I think. It's nice when things work first up. Obviously there's still stuff to do with it. I've got to restring the dial first up, and it's a Philips, but it doesn't look that hard. I noticed the balance control pot is pretty dodgy. I'll have to replace that probably if I can't get it going better. There's all those paper caps to replace, and cathode bypass caps. Give it a good clean up, and it'll be ready to go. The next thing is the turntable, but I'm going to call this the end of part 1 of this series, and I think there'll probably be at least one more. I'll have to do the turntable next, and that'll need the full service, and probably give the cabinet a lick and a promise as well. So I hope you've enjoyed this, and hope to catch you next time. Bye for now.